Yeah, so we are the Panda protectors. And for our project, this 1 week, we have 3 team members, Ellie, Omkar, and Obadah. So we built a project website. It's called about the asteroid. So in this project, we are doing to find the properties that can determine if an asteroid is hazardous or not. So we are using the data connected by the NASA's open API. And to analyze this question, our hypothesis. So we first give our hypothesis of our questions. It's like if the relative speed is large and also the size of an asteroid is small, we think the asteroid may be considered as harmful. So we loaded our data in here. And then the first perspective, I will hand it to Omkar. You can start.
Yeah, so in the first graph, we used a histogram to show the asteroid harmfulness over the years. And you can see there's a spike in 2021, meaning that there was the most number of hazardous asteroids in that year, and it had the greatest sum of relative velocity. Even though the chances of an asteroid hitting Earth was relatively low, it did have the highest chances. And Obadah will go next and go into further detail.
So we put the data above into a pie chart in order to determine the percentage of asteroids that are determined to be hazardous or non-hazardous. And as you can see, only around 5% at most are hazardous at all. And pretty much none of them actually do hit the Earth. So moving on to the next graph, we plotted the relative velocity and the estimated maximum diameter for each asteroid. And using that information, we try to determine if that has an effect on whether it's hazardous or not. And as you can see, if we scroll down a bit, as the velocity increases, you can see a tiny bit of spike in the hazardness count around the 60,000 range, 60,000 kilometers per second. And the maximum diameter didn't really affect it as much as we thought it would. It was around in between the biggest asteroid and the smallest asteroid. So moving on to the next part, Omkar will cover the relation between the average diameter and relative velocity in more detail.
Yeah, so in this section, we talk about the relationship between the average diameter and the relative velocity and how it relates to the asteroid hazardness. And so in the first graph, we used a box plot to illustrate the hazardous asteroids and the non-hazardous asteroids. And you can see that the hazardous asteroids represented by the red has a higher median and a Q1 and Q3 values. So it means that hazardous asteroids tend to have a higher relative velocity than the non-hazardous asteroids. And in the next graph, we look at the average diameter and the relative velocity of both types of asteroids. And you can see that there really isn't much of a difference between those two. And you can also see that the average diameter doesn't really have a factor when it comes to determining the relative velocity or when it comes to classifying an asteroid. And Obadah will cover the next section.
After trying to test and see our hypothesis about the relative velocity and diameter, even after putting them in multiple different graph types, we couldn't really find that much of a result. So we tried the absolute magnitude for each asteroid type. And as it turns out, there is somewhat of a difference, not a total difference. There's like a sort of breaking point in between each set of asteroids. So we determined that the absolute magnitude would be a determining factor in whether or not it would an asteroid would be defined as hazardous or not. And in the next graph, we decided to try and see if the mist distance had any effect on the classification. But then again, as I said before, most of them don't really hit the Earth. They just enter the atmosphere and burn up there. So the mist distance had little to absolutely no effects at all in determining the hazardous or non-hazardous asteroids. So at the conclusion, we realized that the properties that determined if an asteroid is hazardous or not were only the relative velocity to the Earth and the absolute magnitude of the asteroid. And that over time, the frequency of such asteroids has risen, both harmful and non-harmful. But it could possibly be because of the advance in technology. So maybe back in the 1900s, we didn't have as much technology to detect as many asteroids. Our hypothesis only fell short in terms of the diameter or size having an effect on the asteroid's classification, which, as it turned out, was not the case. And that was mainly all our work in this week.
Yeah, so basically, three of our the team members finished this project in this week. But one of them, so Ellie, because she has her own things and she cannot attend this presentation. But I mean, three of them did really good job on this, and they are all hardworking this week. So that's it, for our presentation.
Wow.